Hello everyone, Happy New Year. So, today we will start with backtracking problems and we will try to solve these two problems today. So, first one is palindrome partitioning, and second one is letter combinations of a phone number. And yesterday we have solved, I think, this problem only, word search problem. Okay, after backtracking, we will have I think all the topics will be more advanced topics. So, uh, most probably after tries, I will be again live streaming. Means from graphs we will start solving questions live. So that will be, I think we will be having some fun doing that. So well, let's start with the palindrome partitioning then. Okay, so question says given a string s, partition s such that every substring of partition is a palindrome. Return all possible palindrome partitioning of s. So we are given a string s and we need to make cuts in s. For example, we have this string a b. This is a string and we have to make cuts in this string. Means we have to divide this string into substrings like a and ab is a substring. Means one partition we can do like this. We can make a cut here and we have a and ab, or what we can do, we can make a and b. So this is let's say a string, and we can make cut after every character and partition it into three substrings. But the condition here is we need to make cuts such that after cutting all these substrings are palindrome. So what does a palindrome mean? So palindrome, so a string, uh, a string which is if we read from right and read from left is equal. Means let's take an example, then you can understand. Let's say Nitin. So if we read Nitin from left, Nitin, so it is Nitin from left, and if we read it from right, then again Nitin. So it reads same from backward and forward. So it is a palindrome. Uh, yes, so this is the definition of palindrome, or we can search on Wikipedia. A word, phrase, or sequence that reads the same backwards as forwards. For example, madam, nurses, run, nurses run. Okay, so we have another example, madam. So madam also reads same from left and right. Or we have some other words also. We will not discuss that word here. So conclusively we need to find what we need to find. Okay, we need to make partitions and find all the possible partitions we can make, so that all the substrings after partition are palindrome. So in this split, a is palindrome but ab is not a palindrome, so this is not valid. So not valid. Here in second part, double a is a palindrome. It reads same from backward and forward. B is also palindrome, so it's a valid palindrome. Means valid splits we have made. And this part is also means every string here is also valid. So these are the two our output cases. So and also we can see the input format is pretty small, so clearly we can use backtracking here. Means we can try splitting from every point and move to next what we can say next index. So what we will gonna do is suppose we have this string CAAB. So how we will be approaching this problem is we will start from 0th index and we see if this string is palindrome, yes, then we can uh, remove this substring and add it into our list and move to another string, another means character. And if this is a palindrome till this position, then we have a choice that we can take this or we cannot take this. Okay, means this is a palindrome, we can add this, then again this is a palindrome, we can also add this and move to next index. Now this is not a palindrome, so we will not consider this, we will move again to the next position. So means we will try every split and try to add it into our answer list. So it's pretty hard to explain recursion, so only way is to write the code. So I think we can start with code. So this will be our answer type. Instead initializing it globally, we will initialize it here, and at the end we will need to return this answer. So as we have done in all the backtracking questions, we will call our utility function and will pass this string s, and we will start from 0th index and will pass our current path, which will be a list of string, and also will pass our answer. And whenever we reach let's initialize this utility function starting from string s index and our current path, let's call it current path itself, and also initialize our answer variable. Okay, so currently we are at 0th index. Okay, so starting from 0th index, we will go till length of this string, and we will see if our substring between index means substring between, let's call string, current substring will be s dot substring idx I plus 1. So basically we need to add 1 here because we whatever suppose this is AAB, and if we want this substring, we need to pass 0 and 1 will not be included, means we will always pass 1 plus index, means that's how this function works. So this is our current substring, and we will call a function if our current substring is palindrome. Then what we can do, we can add that our current palindrome to our means current string to our current path, that this current substring is a palindrome, and we have added it to our path, and then we can move to other part of the substring. Means suppose our I is 1, and our, wait a second, so in this string, suppose our index is 0 and our I is, let's say 1. So we will call our substring function 0 I plus 1, which is 2. So this substring will be considered, means we have to pass plus 1 value here. So this substring, so we have passed this substring. Now as this substring is palindrome, so we need to check if our rest of the string is a palindrome or not, and we have added this substring to our current path. Now we will call our utility function, and we will pass here I plus 1, because we have taken a string till ith index. So we will need to check further string s, and also pass our current path and our answer variable. And in order to backtrack, we need to remove that current string from our current path. Current path dot size -1. And here, whenever our index reaches whenever our index reaches at the end of the string s, then we can say that we have successfully found, means our splits are correct. Because if our splits are correct, then only we are calling utility function, means then there is only way we can reach at the end of the string. So what we can do here is we can add that current path into our let's say answer, and we can return. Suppose this is a, and there will be no case that means at least one answer will always be there, because let's say we have a string a b c d. In this case also we will have an answer which will be like a b, means taking every single character. So we'll always have an answer for this question. So now what we need to do is we need to implement this function is palindrome. What our is palindrome function will do, it will check if our current string is palindrome or not. So how we can check, it will be of boolean type, is palindrome. We need to check a string, let's say what we can call this string, let's call st. So we need to check if st is a palindrome or not. Let's take example of Nitin. So how we can check if it is a palindrome or not? So we need to compare this first character with last character. These are equal, then we will move this pointer ahead and this pointer ahead, then we need to compare these pointers, then we reach middle will be equal to itself. So that's how we will check this is a palindrome. Means we will take a pointer at the start position and j pointer at the end position. So let's say start pointer 0 and end pointer at st dot length, mean st dot length minus 1 at the last index. So while our s is smaller than e, so we are ignoring this case for the odd purpose. If instead of Nitin is if it is t, then this will work. So while s is smaller than e, if st dot character at s position is not equal to st dot character at e position, then we can say that it is not a palindrome. Otherwise we will move our s pointer. If these are equal, we will check further and we will decrement our end pointer, and at the end if we haven't found any mismatch, we will return true. So this is the function to check if our string is palindrome or not. Okay. Let's run our function. Okay, we have some issue. Invalid method declaration, return type required. Okay, we need to return void, means we need to return something, so we will return nothing. Okay, we utility spelling mistake. Okay, so I think it's working perfect. A B. We can also take example like ABCD. We can test manually. Let's put ABCD in here. ABCD. Let's run. So in the case of ABCD, we have each character. So let's try to submit this. Perfect. So I think till now it is become clear that we have a template for backtracking, that is we need a utility function. If our some condition matches, then we will add that thing to our current path, and after using that value in current path, we will remove that value from our current path and we will again try to use another path. So all backtracking problems, means almost every problem has this kind of template, but the according to question, the means the demand changes, that validations changes. Okay, perfect. So we can move to next question. Let a combination of a phone number. Okay, it's a pretty famous problem and I think it is widely asked in interviews. So let's read out the problem. Letter combination of a phone number. Given a string containing digits from 2 to 9. Okay, from 2 to 9. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Return all possible letter combinations that the number could represent. Return the answer in any order. Okay. So for each number, for example, this 2, we have 3 keys A, B, and C. I think it's a Nokia 1100, which I am also using. Nokia 1100, and my Nokia 1100 also have a hotspot facility. And 3 represent, for example, DEF, 5 represent JKL. A mapping of digits to letter, just like on telephone buttons. It is given below. Note that one does not map to any other letter. Let's see. Nokia 1100. Okay, so it's Nokia 1100. I think every keypad has digits like this. So the question is saying, suppose we are given input digits 2 and 3, we are given here 2 and 3. So suppose if a person presses 2, and after 2 means any number of time he or she can press 2, and any number of time he or she can press 3. So we need to find all the combinations. So against 2 we have A, B, and C. Against 3 we have D, E, F. So in 2 a person can go for A, and in 3 can go for D. In uh, in 2 he can go for A and B. In B he can go for E, means in 3 he can go for 3. Something like this. B, D, B, E, B, C, D, C, C, E. It's nothing, means we just need to return all the combinations of letters under these digits. Same output we are given. If no digit is pressed, then we are returning empty array. If 2 is pressed, then we only have 3 option A, B, C, and the length of digit is only 4, so it's clearly a backtracking problem. And digits I is a digit in the range 2 to 9. So it's just same another standard problem of backtracking. So what we will do here is, first we will make a array of string. Let's call it keypad. Means in interviews we should use names which make sense, so that interviewer can understand when the code gets complex, that for what purpose a data structure is used. So let's call it keypad. So I think new string. Okay, so we will initialize this array. At 0th position we will put nothing, at 1 position we will also put nothing, and at 2nd position we will put ABC, 3rd position DEF, GHI, JKL, wait a second, JKL MNO PQRS at 7, PQRS UVW PQRS TUV WXYZ. Okay, so we now have a keypad. So this is our keypad data structure, array of string. This is 0th index, we have nothing. At 1 index we have nothing. At 2nd index ABC, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so now we have digits. So we need to return answer in this format, and at the end we will return answer. So we will call a utility function. Okay, a utility function with digits and with our keypad. And with our current path here this time will be a string. So let's use a string builder. String builder means simply we are using an empty string, and we'll pass our answer. Okay, so instead of calling utility for this particular question, we can call it generate, let's say, all the possible letter combination, generate combinations. String digits, string array keypad, string builder, letter means our current letter, and list of string, answer. Okay, okay, we also need to add a index, means which digit we are processing. So digits can be a single, we only have single digits, so we don't need to bother that we can have 2 digits number. So we only have single digit numbers, so we will initialize index here. So if our index reaches, if we have processed all the digits, in that case we will simply add to our answer our letter, and to convert string builder into string we will use function toString, means it will convert letter to string, and then we can return. Okay, so what's our current digit? So our current digit will be, let's say, in digit will be s dot digits dot character at idx position -0. So this will rebase our digit character. It will convert its value into suppose in the case if our digits is 0 -0, so it will simply become 0. So that's what we need. If it's 1, and if we make -1 into this, we will get 1. So that's what we are doing. So this will give us integer value for our digit. So what we need to do then, so we need to then iterate over all values present at these digits. Suppose if digit 2 is pressed, so to find all the combination we need A, B, C. First we will try every combination with A, then B, then C. So we will iterate over all characters present at keypad's second index, means at digit index. So for let's say int I equals to 0, I less than keypad 0, keypad digit. So in the case of 2 this will be 2 and keypad of 2 will be ABC. So its length, it is a string, its length I plus plus, and we will so our current character A will be, so current character will be keypad digit dot character at ith position. So we can, what we can do is we can find our current letter string. We can have a variable, or we can simply go with this approach only. So this will be our current character. We will add this current character to our letter. So letter dot append current character. So we have added current character to our letter, means we have appended A, and we can further call our generate combination function, which will take digits, and we will move to next digit. We will pass keypad, letter and answer. And after trying A, now we need to try with B. So we have added A and we have tried every combination for A, and now we need to try for B. So we need to remove A. So letter dot remove, or I think we can call or delete character at, we need to delete character at last position, that will be letter dot length -1. So I think that is it. This should work. Let's see if this works. Okay, we have got some error. The error is a string builder. There is a spelling mistake, BILD. Let's run it again. Wait a second. Let's run it again. We again got some error. Answer. So don't. Okay, we need to initialize answer. That will be array list. Let's run it now. Okay. We have found all the combination here also and here also, but in the case of empty, we need to return empty list, but we are adding a empty string. So where we are adding empty string, I think we need to remove it from here because we are initializing our string builder as an empty string. Again it's not working. So can we make a condition, add a condition here? Letter dot size should be, means letter dot length should be greater than 0. I think then only we cannot add something into answer. No, we need to add it here. Means if our current letters length is greater than 0, then only we will add it to our answer list. What we are having is we are adding a empty string. Empty string means a string of size 0 into our answer list. That is why we are not getting a empty answer list. So here we are now getting a empty answer string. So I'm thinking, isn't there any way to avoid this without explicitly writing a condition? There is, I think. No, then we need to initialize a string. Let's submit this approach first. Okay, so can we avoid using this extra check? Means while we are converting a empty string builder into string, then we are adding a empty string. Okay, so I can't think of any approach. uh, okay, so we can, I think, end the call here. Sorry, call not. We can end the session here itself. We are left with the n queens problem. Or should we solve it today now? Let's see what the problem says. Okay, so it's pretty standard problem. The problem says we have let's not read out the description. So the problem is simply we are given a n into n size of chess. For example, here our chess board size is n into n, which is 4. N is 4, so 4 into 4. So let me explain n queen problem into single line. So n queen problem is putting n queens in on a n into, where is into, n into n board, so that no queen kills other. queens. Okay, so here n is 4, so let's replace n with 4. So we have to put 4 queens into 4 into 4 board for this particular example I am saying, so that no queen kills other queens. So as we can see, these two configurations we have. So as we know, the queen can move in every direction. Every means in 8 directions. It can move up, down, left, right, and it can also move diagonally. So but here in this board we have 4 queens, so none of the queen is crossing the way of other queen. So what we need to return in this question is, we need to return all the possible arrangements we can arrange these queens, so that a queen does not hinders the way of other queen. So that's the n queen problem, and the format of the output is we are putting a q wherever we are putting a queen, otherwise we are putting a dot. So that's the question, and we will solve it tomorrow. Okay, thank you guys. Happy New Year once again. See you tomorrow.